Hello students, today we are going to learn a very important chapter of maths for a student of grade 6 and onwards, that is fraction. So let's start. Fraction look like this. We will discuss later why some number is on the top and some number is on the bottom, and in between there is a dividing line. In this chapter you might have seen a representation of fraction in the form a whole pizza. One piece is taken out. For example, here it is, and it is written as 1/6 or 1/6. There are many examples here for fractions. You can see here. So the topics covered for this like this, which is being listed here. We will start with its definition, its types, then the fractions, representation of fractions on the number line, and conversion of improper fraction to mixed fraction, how to make equivalent fractions, then some simplification based on fractions, the comparing and ordering of fractions, addition and subtractions, and a little bit of word problems, and I'll be giving some worksheet for you to practice. So as far as the definition of a fraction is concerned, it is nothing but a part of a whole. So fraction means a part of a whole. You can see here, this is a whole pizza and this is a part. Okay, this is a whole pizza and this is a part. So part of a whole is fraction, and it is written in the form of numerator over denominator. So what is numerator and what is denominator, we should know. Number of equal parts taken will be written in the numerator part, and the total numbers of equal parts, the whole is divided into, here for example it is 6, will be written in the denominator. You can see here 6 has been written in the denominator, and this part which is taken out into consideration or taken out, simply you can write here numerator. So numerator is the top number and denominator is the bottom number. In between is a dividing line. You can see here it is divided. So this pizza can be represented as 1/6, this part of the pizza. Likewise here you can also see that if you go on seeing that how many parts, equal parts this pizza must be having. So it is 1, 2, 3, 4, 5, 6 again. So this part can be written as 1/6. Now on the contrary, if anybody says that what these parts are written like, so this will be nothing but 5/6, because see, you can count 1, 2, 3, 4, 5 out of 6. So it is 5/6. Hopefully you understood unto here. So fractions of the shaded portions can be written accordingly. For example, here in this figure, we can see that this figure has been divided into 3 equal parts. So what will be the fractions of the shaded part? You know that it is always written in the form of a numerator over denominator, and numerator is the part taken into consideration. So we are talking about shaded portion. So this is only 1, and out of total 3. So this whole figure was divided into 3 equal parts. So that number we write in the denominator. So for this it will be 1/3. Likewise, if you go for this, think it is 1, 2, 3, 4, 5, 6 equal parts. So that number will be written in the denominator. I can write this. Means we can start writing from the denominator itself, no problem. And you can again count what are the portions or parts shaded. So it is 5. So you can write 5/6 for this. For example, here you have to see that how many parts are there. You can start with like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 we can write in the denominator, and again you can count how many parts are shaded. 1, 2, 3, 4, 5. So 5 will be written in the numerator. So likewise you can write for anything given over here. For example, here for this figure, if you have to write, quite easy, isn't it? Like how many parts are shaded? So 1, 2, 3. 3 parts are shaded among how many equal parts? So you can see that 3 are not shaded, 3 are shaded, total parts are 6. So it can be written as 3/6, which can further be simplified into 1/2, which we will discuss later. Okay. Likewise here you can see 1, 2, 3, 4, 5, 6, 7. So you can write, for this you can write 7 in the numerator part, and it is 7, then 8, 9, 10. So this whole circle is being divided into 10 equal parts. That is why 10 is written in the denominator, and only 7 parts are shaded, so 7 will be written in the numerator. And the rule of writing this is like that: the fraction of the shaded portion will be equal to number of the shaded parts on the numerator side and the total number of parts in the denominator side. Okay, so there is some exercise for you. You can write. For example, here one is given, one answer is given, and I am sure that you can find all the answers very easily. So moving further, we will learn about fractions on the number line. We have already done whole numbers on the number line. Now it is about fractions on the number line. We must know one more thing, that a fraction which is written in the form of numerator over denominator, here if the numerator is less than denominator, the fraction will always be represented between 0 and 1 if it is like this. But if it is like numerator is greater than denominator, so we will see that what whole number is coming and what fraction part is coming. So it will depend where it is going to fall. But if it is like that, numerator is less than denominator, for example 2 by 3, for example 1 by 5, 2 by 4 kind of stuff, we can see that this fraction will be represented on the number line between 0 to 1. Clear? So here, because we have to write the numbers between 0 to 1, so we enlarge the distance of the number line, which is from 0 to 1, so that we can represent numbers. Okay, unit distance, the distance between 0 to 1. Now, according to the fractions given in questions to represent on the number line, we divide this unit distance into the equal parts. For example, if it is writing 2 over 5, so we can see that the unit distance needs to be divided into 5 equal parts. So from 0 to 1, we can divide this into 5 equal parts: 1, 2, 3, 4, and 5. And we will just count the numerator number from 0 onwards, like 1, this is your 1, and this is your 2. And this is actually the representation of 2 over 5. How? You can see here 0 can be written as 0 over 5. Because it has been divided into 5 equal parts, it will be your 1 by 5. This is going to be 2 over 5. This is going to be, and this is 4 over 5. And here, yes, it is 5 over 5, which is equal to 1. And that is why 1 is written. So now you can see if they are asking about to represent 2 by 5, this is the place, the position in the number line. You can represent 2 by 5. For 4 by 5, this will be the position. So it is clear to understand. I have given you something here like a number line from 0 to 3. So in between we can write many numbers. For example, if it is from 0 to 1, that is the unit distance is divided into 5. So naturally we will write 5 as the denominator. Also we can see that from 1 to 2, it is being divided into 5 equal parts again, and also from 2 to 3, the same case is here. So that is why we have written 5 in the denominator for all the position here. Now for this point, you can see that it is going to be 1 because 0 is here. So after that it will be 1. We can write here 1. So this is represented as 1 over 5, or 1 by 5 will be represented here on the number line. So 2 by 5 will take this position, 3 by 5 will take this position, 4 over 5 will take this position on the number line. Likewise, as you know that it will be 5. So just start counting. The natural number is coming up over here, you can see. And if this is 0, the whole numbers. So yes, it will be 6 over 5. It will be 7 over 5. Then 8. Then 9. Then further it will be 10 over 5. And we know that the 10 over 5 means 2. Likewise, 5 by 5 was 1. Okay. So here for 3, you can see it will be 15 over 5. 15 over 5 will give you 3, and this is the 3 in the number line. So 11, 12, 13, and 14. So if anybody asks you to write or represent a fraction which is an improper fraction, actually we will discuss later, whose denominator is greater than numerator is greater than the denominator, then what happens? It goes beyond 1 on the number line. See, to here you can see that the denominator and numerator is same, that is why it is 1, but after that the numerator is increasing 6 over 5, 7 over 5, 8 over 5. So these are the numbers which are more than 1. Okay, so if the number is more than 1, it is an improper fraction. We will discuss later. Few more examples for this is like this. You can see here that it is been already represented as 2 by 5. So if I ask you, show me where is 6 over 5, then you will come to know that this is greater than 1. See, 6 over 5 means it is more than 1. So naturally we will look over here, somewhere here. But okay, no problem. We can always think from here that it was 0 over 5. This was your 1 over 5. Like this is 2, 3, 4, 5. And then this part is going to be your 6 over 5. Very easy. Because the unit distance has been divided into 5 equal parts. Okay. So now here you can see that the unit distance has been divided into how many parts? 7 equal parts. Here from 0 to 1, this unit distance has been divided into 7 equal parts. So finding the fractions which is less than 1 is very easy, whose denominator will be 7. For example, here it is 3 by 7. See, 4 by 7, 1 by 7. Now if anybody asks you what is the fraction that we can write for this point on this number line, just think. So first thing we have to think is how many parts, equal parts, this unit distance has been divided into. So we will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if it is 12, then 12 will be written in the denominator part. And now for this point we will count that where does it lie. So it is 1, it is 2, this is 3, it is 4, and this is your 5. So it is going to be 5 over 12. So 5 over 12 is your answer. So likewise, I guess we can find the answer over here as well. Okay. Yes, that the unit distance is divided into how many equal parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We saw that it is 10 equal parts. It is divided into 10 equal parts. 10 will be written in the denominator. And where is the position on the number line for this fraction? It is 1, 2, 3, fourth position. So it will be 4 over. I hope you understand. Now we will discuss about types of fractions. So basically there are proper fractions, improper fractions, and mixed fractions. Further you can have the names like equivalent fractions, unit fractions, and many things are there related to fractions. But the major thing that we learned is proper fraction, improper fraction, mixed fraction, and equivalent fraction. So what proper fraction is? The definition is already given. It is nothing but when the numerator is less than the denominator. That's it. What improper fraction is? It is nothing but when, that means numerator is greater than the denominator. And mixed fraction is what? It is a whole number followed by a proper fraction. It's called mixed fraction. The word is mixed, so it will be a mixture of two things. One is the whole number part. You can see here one is a whole number part. Okay, it is a whole number. So this is a whole number part, and 2 by 7 is a fraction. And what kind of fraction it is? You can see 2 is the numerator, which is less than the denominator 7. So it is a proper fraction. So you can see here in the definition it is written the whole number followed by a proper fraction. You can see here whole number and the proper fraction. So mixture of this is known as mixed fraction. Okay. Yes. There were two more which I could not tell you earlier, that like fractions and unlike fractions. So what are like fractions and what are unlike fractions? Like fractions which have the same denominator are called like fractions. Here you can see in the examples given 1 over 7, 2 over 7, 5 over 7. You can see that in all the fractions written here, the denominator is 7. So denominator is same for all, then this will be known as like fraction. For the example, you can have like 2 by 11, 3 by 11, or 9 by 11, even 10 by 11. No matter how many numbers you can write, okay, all are having the same denominator, so it will be known as like fractions. And on the contrary, unlike fractions will not have the same denominator. For example, 1 over 7, 2 over 8, 2 over 9. So 7, 8, 9 are not equal, so they are known as unlike fractions. Very easy. Now, as we came to know about improper fractions and mixed fractions, we also learned about the conversion of improper fraction into the mixed and vice versa. So there is a rule actually how to convert from improper to mixed fraction. For example, if I give you a question 9 over 4, this improper fraction will be converted into the mixed fraction. Okay, we have already have one course here. Convert 13 over 7 into mixed fractions. So the rule is given. If you follow the rule, divide and find the remainder. It means, see, a fraction is also a kind of division where numerator is a dividend and denominator is a divisor. So 13 over 7 can be written as 13 divided by 7. Okay. So what we are going to do is we will divide this numerator by the denominator and we'll see what is the quotient coming up. So if you do like that, 1 will be the quotient, 7 times 1 is 7, and if you subtract you get 6 as the remainder. So this is your remainder and this 1 is your quotient and this is your divisor. So what they are saying, write in the form of Q whole R over D. So where is Q? 1. So you will write for this 1, this will be written as 1, which is the Q. Okay, and then you will write this a dividing line in from the middle of this whole number, and you will write what the remainder is. So remainder is 6, and you will also write what the divisor is, or simply it is the denominator. So 13 over 7 can be converted into mixed fraction as 1 whole 6 over 7. Likewise, 9 over 4 you can write. What we are going to do, 9 will be divided by 4. Okay, in the division method, we will see what is the quotient remainder coming up. So 4 times 2 gives you 8. If you subtract, you get 1. So the remainder here is 1. The quotient here is 2. And if we have to write this in the form of Q whole R over D, we can write it as, where is the Q? Here 2. So you will write 2 and you will write the remainder as 1 over the divisor, that is the denominator. So the denominator is always written here. This is your quotient and this is your remainder. Now converting mixed into improper fraction. Yes. So see the steps written down here. Multiply the denominator by the whole number and then add the numerator to get the new number. Okay. Second step is write the original denominator below the new number. Very easy. For example, I have given you a question here. 1 whole 3 by 5. So what they say, see, multiply the denominator by the whole number. We know that this is our whole number. They say that multiply the denominators. This is our denominator, so we are going to multiply this. Okay, and now what they are saying, then add the numerator. Okay, so when we multiply this, we get 5, and they are saying then add this to numerator. So we will add these two and we will write here. So 5 plus 3 gives us 8. We will write 8 in the numerator part and the denominator will be here. You can see what it was done. 5 multiplied by 1 and then added to 3 will be written as 5 times 1 plus 3 in the numerator over the same denominator will be written here. So it will give you 8 over 5, the same. This is the process we can follow. Very easy. For example, if I give you a number like 3 whole 2 over 5, very easy. What you will be doing? You will multiply this denominator to the whole number, okay? And what you get is 15. So you can write here 15, no problem, plus the numerator of this fraction part, that is 2. You can add them and write in the numerator, and this 5 will be written down here. So it is 17 over 5. If you can add this in your mind, your mental math is good, then you can directly write this to this. Okay, no need to go in between. Now we will learn about equivalent fractions. So what equivalent fraction is? You can see here with the representation of this circle, which is being divided into two. Here this is divided into 4 equal parts. Here it is 6, and here we can see as 8. But the shaded part, from the shaded part of all these circles, we can see they're same. I mean, it has taken half of the circle. These two parts of the shaded taken half. This also has taken half. This also have taken half. So shade the area shaded in these circles are same here. It means whatever fractions we will be writing according to the shaded portion will be the same in value. So here we know that it is 1 out of 2. So we will write 1 out of 2, 1 over 2. These are the two shaded parts out of 4, so it will be written as 2 by 4. We have already done it earlier. 3 shaded part, 3 will be written on the top, and how many equal parts are there? 6, so it will be written 3 by 6. Likewise, it is 4 by 8. And we can see by the figure that all should be equal to each other. So we can easily write 1 over 2 is equal to 2 by 4, which is equal to actually 3 by 6, which can also be equal to 4 by 8. And these are known as equivalent fractions. So what happens in equivalence fractions? It represents the same portion of a whole. Okay. And also the value wise, it never changes. I mean, 4 by 8 was nothing but 1 by 2. It was nothing but 2 by 4. And it was nothing but 3 by 6. Figures are different, you can see, okay, in the numerators and denominators. But the value wise, it will be same. So the same value, the fractions having the same value with different figures in the denominator and numerator are known as equivalent fractions. For example, I have given you some questions. Now, you can see here, this circle is being divided into 1, 2, 3, 4, 5 equal parts. One part here is shaded, so we can easily write 1 over 5, isn't it? Now here, we can see that the two equal parts have been shaded. Out of how many equal parts? It should be 10. That is why it is equal to this. Okay. For example, 5 over 8 will be equal to which fraction, and also it is going to be equal to which fractions, where in one fraction denominator is given and in other fraction denominator is given. So how do you find this question mark number? Yes, we will see the ratio. Okay, that from 8 to 24, we got it by multiplying 3 to 8. So from 5 to this question mark number, if we have to find, we will do the same as we have done it in the denominator, that we will multiply 5 to 3 to get this number. So here we are going to get 50. Likewise, if we see that what number is going to be here, okay, for this, where the numerator is 35. So we will see the relation from this numerator to this numerator, and we check and saw that it is obtained by multiplying by 5 to 7. So if we multiply 5 to 7 to get this numerator, so to get the denominator, we have to multiply this denominator to 7 again. So it is going to be 56. So 5 over 8 is written as 15 over 24 as an equivalent fraction, and also 35 over 56 as an equivalent fraction. Easy? Now moving forward, we have to look over what does simplifying the fraction means. After knowing all these things, we start our exercises with simplification of fractions. Okay, so the very first thing is that the fractions will be having a big number in the numerator and the big number in the denominator, and if there is any common factor between them, we just take them out and make it simpler and smaller. So it is also known as the lowest form. So 12 by 40 is a fraction. We see here that there is something common between 12 and 40 because they are the even numbers. So easily we can see that we can divide this by 2. We can divide this by 2 further. But we can go further to see if we have any greater common factor, GCR. So we see that 4 is the greater common factor from which we can divide this 3 times. and we can divide this by multiplying 4 to 10. Okay, so this is the lowest form. Why? Because we cannot find anything common between 3 to 10 to further simplify or make it low. This is how we do. We find the common factor. If you can find the greatest common factor in the very first attempt or one shot, you can get the answer. Otherwise, you can take 2-3 more steps like that. Okay, here we can see 51 over 68. Though the 51 is not an even number, 68 is even number, so we cannot divide them and think that 2 could be the common factor. So we will move forward and see what other prime numbers can be the factors, okay, or any number. So here we will think about 3. Yes, 3 can divide 51. You know the divisibility rule. 5 plus 1 makes it 6, which is divisible by 3. So this 51 will be divisible by 3. And what about this 68? No, 68 is not divisible by 3. So we can go further and check. So I think that 17 is a number that divides 3 as well as 4. So the simplest form of 51 over 68 will be 3 over 4. You should memorize the tables also. Up to 20, if your table is okay, then these numbers, finding the common factor between the numbers will be very easy for you. Okay. Now for this, we can start with C2, because we can easily see that 2 is the common factor, having these two numbers as even number. So we will divide this by 2 first. So 2 12 times, 2 30 times. Again, we see these are the even numbers, so we can go further again. 2 times 6, 2 times 15. Okay, now we can see that these numbers are also having common factor as 3. So 3 times 2 and 3 times 5. So after these many steps, we can now find that 2 by 5 is the lowest form of this fraction. Simplified. Here, 3 times 7, 3 times 12. Okay, so 7 over 12 will be the simplest form or the lowest form. Divide numerator and denominator of fractions by common factors till the fraction is in the lowest. When it comes to comparing, so we compare between two numbers with the signs like greater than, equal to, or smaller than. So between these two, 5 over 8, 7 by 8, it is quite easy to understand when the denominators are same of the fractions which are going to be compared. The lower the numerator, lower is the number. So it is obviously smaller than 7 by 8, isn't it? Likewise, if I give you more examples, for example, 2 over 11 and 9 over 11. Quite obvious, 11 here, 11 here. The denominators are same, so whichever numerator will be smaller, that is going to be smaller. Whichever numerator will be greater, that fraction will be. So these are the like fractions. So comparing like fraction is very easy. Okay, a little bit difficult could be about comparing the unlike fractions. Here we can see 2 over 5, 3 over 8, where the denominators are not same. That is why they are unlike fractions. So what do we do? Because there are two methods. But the very first method is like this. The very first method is like this. Do you understand? Okay. So we go cross multiplication method. We go by cross multiplication method. And what we did here is we will rewrite these fractions, okay, as an equivalent fraction. That what an equivalent fraction. So here see, simply 8 times 2 is 16 coming up. And here 5 times 3 is 15 is coming up. Which number is greater to which side? Okay, the number 16 is greater than 15 and 16 is on the side of 2 over 5, 15 is on the side of 3 over 5. So 16 is greater than this, so we can easily write that 2 over 5 will be greater than 3 over 8. Okay, this is one method. And the other method is to make these fractions like fractions. I mean, making their denominators common so that you can easily find which is greater and which is smaller as per the numerators. Okay, so what are we going to do here? See, that if the number is 2 over 5 and 3 over 8, as I said, that we will first make it like fractions, convert these fractions into like fractions. Okay, so in order to make these like fractions, what do we do? First, we will make these denominators equal. So how can we make these fractions? So how can we make denominators equal? It is when we multiply this by 8 and when we multiply this by 5. Why? Because we can make them equal only when we find the LCM of 5 and 8. So what is the LCM of 5 and 8? It is 40. It means we have to make these fractions in the form of a fraction whose denominator will be 40. So from 5 to 40, how did we get? Multiplied by 8. So we will multiply this by 8 as well. So this is going to give us 16 over 40. And to make this 40, we multiply this by 5. So we will multiply the numerator as well by 5. So this will give us 15 over 40. Now it is quite clear that 16 is greater than 15. So it is going to be like this. Now 16 by 40 is an equivalent fraction of 2 over 5. And 15 over 40 is the equivalent fraction of 3 over 8. So we will write like this and make the signs. Some examples related to mixed fractions. So yes, we can find without changing these mixed fraction into improper fraction, but the best way is to convert these mixed fraction into improper fractions, and then through the previous method we have solved. For example, here you can see 2 whole 2 by 3, 1 whole 1 by 3. It is, by the way, very much easy to find, and we can easily write this is greater than this. Why? Because see, the whole part is here, which is greater than the whole part over here. So anywhere when the whole part is greater, that will be greater. Okay, if the fraction part is proper fraction, if these fractions are proper fraction, then we can check with the whole number. But in somewhere like here, if the whole number is same, then we have to just check with these two fractions which is greater and which is smaller. Whichever is greater, that will be the greater. Okay, so 5 over 6 and 3 over 8, we do like this. We will ignore 1 here because 1 is here as well, 1 is here as well. So we will just think that we have 5 over 6 here and we have 3 over 6 here. In between them, whichever will be greater, that mixed fraction will be greater. Okay. So what was the rule? Actually, you will multiply this to this and think what number is coming up. It is coming up 40 here. So this side it is coming up 40 here. If you multiply this to this side it is coming 18 here. So 14 is greater than 18, right? It means 5 by 6 is greater than 3 by 8. So 5 by 6 is greater than 3 by 8. 1 is here as well added and 1 is here also added. So this is going to be greater. Very easy. Here also you can see that 2 is here, 2 is here. We will ignore this and we will compare about this 3 over 5 and 3 over 4. Now 3, a number which is divided by a greater number, and 3 is a number which is divided by a smaller number. So which is greater? A number which is divided by a smaller is greater. So it is very easy, isn't it? If the numerators are same and the denominators are different, finding, for example, 4 over 3 and 4 over 2. So which is greater? We are dividing 4 into 3 equal parts. Okay, 4 into 3 equal parts, and we are dividing 4 into 2 equal parts. So naturally this will be greater. Why? Because if we divide 4 equal parts into 3, the number is going to be less compared to 4 divided by 2. So this is another method we can think of. Here again we see that 1 is here, 2 is here. Very easy. It will be greater. No need to see here 1, we will ignore this and we'll think of 7 times 2, that is going to give us 14. 8 times 1, that is going to give us 8. 14 is greater than this. So this here we will write this sign. Okay, greater than 1 over 7 by 8 is greater than 1 whole 1 by 2. So likewise, I think you can do the others. I hope you will do this. Now we are here for finding the orders of the fractions given. If it was a like fraction, it would have been very easy, right? Like 2 by 11, 4 by 11, 5 by 11 or 6 by 11. So these are the like fractions. So for like fractions, putting them in order is quite easy because you see which is the smallest one. So in ascending order, we will write 2 over 11, is smaller than 4 over 11 is smaller than 5 over 11 is smaller than 6 over. So we can write like this. It is known as writing in ascending order. Okay, in ascending order means you will start with the smallest one and end up with the greatest one. In between, it will be gradually written a little greater than this, and then greater than this, and then the greater than this, the greatest in the last. In descending order, it is opposite. You will start with the greatest one and end up with the smallest one. Okay, so ordering unlike fractions, if I give you write it in ascending order, then how do you write? Because these fractions are not like fractions, they are unlike fractions. So how do we write? There are numbers 3 over 4, 3 over 19, 15, 12, and 7. Too big, okay? Let's start with this one where 2, 5, 4, and 10 is. It is easier than that. Do you think that? No. Actually, see, you may not have noticed that the numerator everywhere is same. 3, 3, 3, 3, 3. So as I said that if the numerators are same and denominators are different, even in that condition, okay, finding the orders is very easy. How? The greater the denominator, in this case, the greater the denominator, the lesser the number. Isn't it? For example, you can see that if we have a chocolate bar like this, okay, which has 3 small bars in this chocolate, 3 squares, you can say, a rectangular shape. What happens here is if this chocolate is going to be divided into 4 portions, naturally someone will get like this, okay, like this, and this. I mean, this part at least is going to be given to one person. But if the same chocolate, okay, is divided into 19 equal parts, 19 among 19 guys, then just imagine how many parts will be given to one smaller. So in this scenario, if the numerators are same, the lesser the denominator, the greater the number is. The greater the denominator, the lesser the number is. So in order to write this in ascending order, you can see that 3 by 19 is going to be the lowest one. After that it is 15, so you can write 3 over 15. After that it is coming 12, so you can write 3 over 12. Likewise 3 over 7, and then finally 3 by 4. So 3 by 4 is the greatest one and 3 by 9 is the smallest one, isn't it? Now come to this where we don't have this scenario. So we had seen 2 scenarios that when the denominators were same, we compared them easily. When the numerators are same, we also compare that very easily. Now for these fractions, how do we write them in orders? We can rewrite these fractions into their equivalent fractions with the common denominators in all. So if we can find any number that can make all these fractions equivalent with the common denominators, that will make our task easy because we can compare that with numerators only. Now for a question like this where all the fractions are unlike fractions having different numbers in numerators and denominators, so the rule to find them in orders is to find the common denominator for all of them. In order to find their common denominator, we take out all the denominator and find their LCM. So you know how to find the LCM of the given numbers. Okay, so we see that 2 and 4 and 10 the even numbers can be divided by 2, so we just took 2 here and divide them. Whatever quotient comes up, we write over there. Which is not divisible, we write the number same as it is. Okay, so now here we can see 5 and 5 here, so we can take 5 as a common factor of all these 2 numbers. So we can see that 5 times 1 and 2 is not divisible by 5, so we will write 2. 5 is divisible, the quotient comes 1, we will write quotient 1 here. So the LCM is written like this. So LCM will be this number multiplied by this number, this number, this number, this number, and this number. So writing 1 is not good idea. So we can see just 2, 5, and 2 getting multiplied. So 20 is going to be our LCM. It means it means it gives an idea that if we can convert all these fractions into the equivalent fractions with the denominator 20, okay, it will be very easy task for us. Now 1 by 2 can be converted into a fraction whose denominator will be 20, means you are going to multiply this by 10. Okay, if you are going to multiply by this by 10, you will also multiply this by 10. So this is going to be your 10 over 20. Likewise, if you see, if you want to make this 520, you have to multiply this by 4. So you will multiply this by 4 to make it equivalent. So it is going to be 8 over 20. Likewise, you can see 4 times 5 make is 20. So 3 times 5 will make it 15, or 15 will be written in the numerator, 20 here. Likewise, you can see 10 times 2, 7 times 2, 14 over 20. Now it is very easy that how these can be ordered. The smaller is 8 over 20. So 8 over 20 is for 2 over 5. So I can just delete in order. 8 over 20. First we will see that 8 over 20 is the smallest one, and then 10 over 20 comes up, then 14 over 20 comes up, and the greatest one is 15 over 20. Now we will not write these numbers in the answer, okay, because the actual numbers in the question given are 1 by 2, 2 by 5, 3 by 4 and 7 by 10. So what we had made this 820 from, we will check. So 820 was actually made from 2 over 5. So we will write 2 over 5. In the next number, it will be 1 by 2. 14 by 20 was actually nothing but 7 by 10. So we can just write the actual numbers of the questions given. 15 by 20 was nothing but 3 by 4. And the orders will be like this. So this is your final. Now a little part of addition and subtraction. So here you can see if the fractions are like fractions, addition is very easy. What do? We just write a denominator and we add the numerators and write in the numerators. Okay, so it will give you 6 over 7. Very easy, isn't it? Like if I give you a number 3 over 8 plus 5 over 8, okay, then what will be your answer? You will just write a dividing line here a little bit bigger than this single fraction. Now you see 8 will be written. Why bigger? I mean, you have to write the addition of these numerators. So you need a little bit larger in size. So you just did like that. You can find 8 over 8. 8 over 8 is nothing but 1, because same number on the top, same number on the bottom makes it equal to 1. Okay. When it comes to subtraction of the like fractions, it is also very easy. We will do nothing. We will let's draw this dividing line. Write then denominator which is given here in the denominator here, and we will see what is the first numerator. We will write the first numerator. The sign is negative, I mean subtraction sign. We will write subtraction sign. Okay, and then this 3. So it will give you 2 over 8. 2 over 8 can further be simplified, okay, because we have learned the simplification also. So we will simplify it until we get the lowest form of this. So the lowest form of the fraction will be 1 by 4. Okay, and this will be our answer. For example, here if I give you 9 over 11 minus 5 over 11, so your answer will be very easy. What you will be doing, you will write this common denominator here. The very first fraction has the numerator 9, so you will write 9. It is a subtraction, so you will write the minus sign, and the next numerator is 5, so you will write 5. And now you will do some calculations. Here it is going to be 4 in the numerator side, and here it is 11 in the denominator side. So your answer for this question will be like this. Now when it comes to adding unlike fractions, what it takes. So see here, I have given you an example, 2 over 3 plus 3 by 4. So 2 over 3 by 3 by 4, how can you do that? See, there are two methods, but the very simple and easy method is converting them into equivalent fractions with same denominator, common denominator. What? Converting the fractions or writing the equivalent fractions of the given fractions with the common denominator. That should be your goal. It means 3, a denominator here is not going to be 3 if you just convert this into equivalent fraction. Likewise, 4 here will not be the 4 here if you write the equivalent fraction. Okay, so in order to find the equivalent fractions, the simple method is the numbers are having no common factor, then you can simply multiply these numbers, okay, and that is going to be your number, okay, which you are going to find. So 12, it means you have to make this 12, you have to make this 12. So from 2 over 3, now you just see if 2 over 3 has to be made an equivalent fraction with denominator 12, what you have to do? You just saw that you multiplied this 3 to 4 to get 12. So you will also multiply this to 4 to get the number here. That will be 8. It means 2 by 3 can be written as 8 by 12 as a form of equivalent fraction. So 3 by 4, you multiplied 4 to 3 to make it 12, isn't it? So you will multiply again 3 to 3 to get it here. So it will be 9 by 4. Now it is easy. For you, it is easy now. You can see that earlier what we did, we write this denominator, common denominator, okay, as a single denominator, and these are added up. Numerators will be added up. And your answer is going to be 17 over 12. Which is an improper fraction. You can see that the numerator is greater than the denominator. When the numerator is greater than the denominator, it is called as improper fraction. So improper fraction is always changed into or converted into mixed fraction. And you know the rule of converting an improper fraction to mixed fraction. So the final result is going to be what? Think. It is going to be 12 times 1 makes it 12. 5 is your remainder, and the 12 is your 1 whole 5 over 12 is your answer. Now for these questions. 5 and 3 having no common factor, it means we can find LCM of them, that is 15. 5 times 3, 15, isn't it? So we have to convert 2 by 3 with a number that can give us 15 as a denominator. Like see 2 by 3, we need to make it 15, so we will multiply this by 5. Now plus 1 by 5, we have to make this 15, we will multiply this by 3, we will multiply this by 3 to make it equal. Now we got the new numbers as 10 over 15, and here we got the new number as 3 over 15. When we add them, directly I am writing, or you can just do practice with this. The answer is going to be 13 over. Here also 9, 7 having nothing common factor in between. So simply we will multiply and get the LCM. 9, 7 times is 63. It means simply you can see that if it is getting multiplied, okay. So we will multiply this by 7 times to make it 63. Okay, so again 77 will be here as well. Here we have seen that 9 times we will multiply. Now get the new number. It is going to be 14, 63 plus 27, 63. Okay, 63 will be written in the denominator. 14 plus 27 will be written on the numerator. If you add them, it will be 4, 1, that is 41 by 63. Nothing is common between these two numbers, so that we can simplify further. Now you will do this. I hope you can do. When it comes to subtraction of the unlike fraction, the same thing happens. Okay, same thing. I mean, you see 5 and 3, 3 and 5. The LCM you will find out. LCM of 3 and 5 gives you 15. It means 2 by 3 has to be changed into a number whose denominator will be 15. So to make it 15, you will multiply this by 5. So you can rewrite this 2 by 3 in the form of, and then this will be sign. We are going to subtract, right? So minus sign will be written. 1 over 5 can be rewritten as what? Whose denominator has to be 15. So 5 times 3 makes it 15. So 1 times 3 will be written. Now you see the very first number for you is going to be 10 over 15, and this is going to give you 3 over 15. Subtract this is quite easy. You will do the same process. 15 will be written as the common denominator, 10 and minus 3 will be written in the numerator. It is going to be 7 by 15. That's the answer. So here directly see there is one more method which I want to tell you. You can see there is nothing common. The LCM is going to be 14. LCM is going to be 14. So directly we write 14 as the denominator. Okay, see my step. I mean directly this step we are going to write. Directly from here to here directly we are going to write. How? We got 14 as a common denominator, finding its their LCM. So LCM of 2 and 7 is 14. We'll write 14. Now from the very first fraction, this 14 will be divided by the denominator. What? Divide this common denominator or the LCM by the denominator of the first fraction. So you get what? If you divide this 14 by 2, you get the quotient 7. Okay, now that 7 that we got will be multiplied by this one. Understand? So this 7 will be multiplied by 1 to give you 7. Again, in the same process, you will divide this 14 by 7. So if you divide 14 by 7, your quotient is 2. Then that 2 will be multiplied by here to give you the number here. So 2 times 3 will give you 6, isn't it? So 7 times 1 was going to give you 7. 2 times 3 was going to give you 6. So see, I mean here the quotient is different. The step is the same. So 1 over 14. How easy it is. You can do the same here. What? 4 and 6. There is a common factor too. Okay. So 4 and 6 will give you LCM not 24. It will be 12 if you find. Okay. 4 and 6. The LCM will be 2 times 2 times 3. That is 12. So this is your LCM of 4 and 6. It means 12 can be written as the denominator. Now, as I said, divide this 12 by 4, get the number. That is what? If you divide this 12 by 4, you get 3, isn't it? And then this 3 will be multiplied over here, this numerator. So it is going to give you 9. Divide this 12 by 6, that will give you 2. And then multiply this by 1, you will get over here. So 3 times 3 gives you 9, 2 times 1 gives you 2. Now you subtract this, okay, and get the answer. So easy. Without going through the process of converting them into equivalent fractions with the common denominator, you can do like this. So this is the faster way. Okay, so whichever way you like, you can write in the comment, and please do some practice. You cannot have fractions always improper or proper. There could be fractions like mixed fractions, okay, that are going to be added or subtracted. So the simple method is you will convert these mixed fraction into improper fractions. So 5 times 3, 15 plus 1 is 16. So 16 over 3 is coming up here. Likewise, 6 times 5 is 30. 30 plus 2 is 32. 32 over 5 is coming over here. So you have got two fractions with, okay, a single numerator and denominator kind of stuff. And now you can follow the same rule, okay, of addition. Like 5 and 3 having no common factor may give you LCM of 15. So 15 can be written directly. Now, as I said, that please divide this 15 by the denominator of the first fraction, get the quotient, multiply the quotient to the numerator. So 3, you divide 15 by 3, it gives you 5. 5 must be multiplied by 16. So 16 times 5 is 80. Okay, if you divide this 15 by 5, it gives you 3. 3 times 32 is how much? 96. Now your answer is ready. You just see what number is coming up. 176 over 15, which is an improper fraction. So your answer is going to be in. So to find the mixed fraction, you will do the division method process to find what is the quotient, what is the remainder, and you know how to write them, like quotient, whole number part, then remainder here as the numerator and the divisor here as the denominator is the format of writing mixed fractions. So you see, 1 time 15 is going to be there, 2 will be the remainder, 6 will be taken down. Now 15 times 1 again can go, because 15 times 2 is 30, which is greater than 26. So we will see that, okay, the remainder is 11. So remainder is 11, quotient is also 11, and the whole number is actually what we write from the quotient. Remainder is what? That is written here on the numerator side, and this is always written the denominator here. So this is your answer. One more example here, you can see it will give you 6 times 3, 18, 18 plus 1, that is 19, 19 over 3 minus 5 times 3 is 15, 15 minus 15 plus 4, that is again 19, 19 over 5. Oh, so this is like that. And again, we have to convert these into equivalent fractions. So our method was multiplying this and getting the LCM, that is 15. 3 times 5 is 15. 5 times 19 is how much? 95. 5 times 3, 19 times 3 is how much? 5 times 3 is 15. So 3 will be multiplied by 19. So how much? 57, right? So you see, if you subtract these, what number you are going to get? Yes, 38? 38. 38 over 15. 38 over 15 can be rewritten in the form of a mixed fraction, that is 15 times 2 makes it 30. If you subtract 30 from 38, you get the remainder as 8, and 15 will always be written. So this much quick you can do this. So this is for you, and this is. So let's have a look at a couple of word problems on fractions. The very first question says Jenny has 8 vanilla flavored ice creams and 4 strawberry flavored ice creams. So we can always mark that 4 strawberry flavored ice creams, and this 8 vanilla flavored ice creams. So you can see that the total number of ice creams is going to be 4 plus 8, that is 12. Is that clear? Because they are asking what fraction of the ice creams is strawberry flavored. So we will also find out what is the number of strawberry flavor. So number of strawberry flavored ice creams is 4 here. So when we have to find out the fraction, so the number of strawberry flavored ice cream will be written as a numerator, and the total number of ice creams will be written in the denominator for getting the answer of this question. So now this is going to give you 4 upon 12, which will further be simplified to 1 over 3, because 4 is the common factor of 4 and 12. So 4 times 1 is 4, 4 times 3 is 12. So 1 by 3 is your answer. I hope you understand this. Next question says that Evie has completed 36 lengths of her swimming challenges. This is 3 by 4 of total. How many more does she need to swim? So you can see that this kind of question, for solving this kind of a question, we need to draw a figure like this, where we will be distributing this into 4 equal parts. Let's try whether we can do this or not. Yes, 4 equal parts. And they are saying that 3/4 means, you can see here, this is your 1 unit, okay, length. This is another 1 unit length. So 1 unit length, 1 unit length, and totally it is going to give you 4 unit length. So 3 unit length is equal to 36 lengths, okay. 3/4 or 3 by 4 of the total. 3 by 4 is this. 3 out of 4 is 3 by 4. 3 out of 4. So I have that. That is why I made this bar into 4 equal parts. And now 3, we will be shading this 3 like this, that they are covered. Okay. Now they are asking how many more lengths does she need to swim. So this is the length she has to swim. And now if it is 36, we have to find out what is the 1 unit length equal to in lengths. So yes, we can find 3 unit is equal to 36 lengths here, isn't it? 1 unit is going to be equal to how much? 36 divided by 3, that will give you 12 lengths. And we have to find out only the length that is equal to 1 unit. So our answer is going to be 12 length only, and this is your answer. I hope you understand. So finally, as promised earlier, this is your worksheet. Some questions are there related to what I have taught you today in this video that you will be doing at home, and I'm sure this is going to help you out for the preparation of exam. Thank you for being with me for the whole lesson. Bye. Take care.